Hello everybody and welcome to Cellix's webinar on VenaFlux platform and biochips applied in studies of leukocyte adhesion and inflammation. My name is Dmitry Kashanin and I'm glad you could join us today. The agenda for today is as follows. I will start with introduction of Cellix's VenaFlux platform, and then we proceed to one of the applications, inflammation and leukocyte adhesion, and we will finish with a quick summary of this application. Cellix's VenaFlux platform provides a complete integrated tool which allows mimicking physiological flow and shear stress in microcapillaries, venules, and arteries. Very similar to intravital microscopy, it allows to visualize cell rolling, cell adhesion under shear stress, and the shear flow. It is a very functional assay for activation of leukocytes and activation of cells, and cell interaction with capillary wall can be observed and easily quantified. The heart of the Cellix's platform is Biochips. We have a line of Vena Biochips. The first one in line is the Vena 8 Biochips. This can be used for bright field and phase contrast microscopy and contains 8 microcapillaries with dimensions of 400 microns by 100 microns deep. This allows the observation of cell interaction with coated ligands or adhesion molecules, cell rolling, cell adhesion, and cell migration on the flow. If it is necessary to use fluorescent microscopy or very low fluorescent signal in conjunction with confocal microscopy, we recommend to use Vena 8 fluoroplast biochips, where it has improved optical clarity and also very thin substrate of 0.17 millimeters, which allows observation with high numerical aperture objectives and oil immersion. This biochips has similar dimensions to Vena 8 biochips and also has 8 microcapillaries on the chip. If it is necessary to conduct experiments where cell-to-cell interaction needs to be observed, like interaction with leukocytes and endothelial cell cultures on the chip, we recommend to use Vena 8 endothelial plus biochip. This biochip contains 8 microchannels, slightly wider, 800 micrometers, and deeper, 100 micrometers deep, which allow successfully to grow confluent monolayers of endothelial cells and easily and robustly run the cell adhesion and cell rolling assay on the flow. Cellix's Vena EC biochips allow to use different substrate materials and grow different cell lines on those substrates using a conventional incubator and 6 well plates. It has 2 channels on the top cover which seal against the substrate material. Dimensions of the channels is 600 micrometers by 100 micrometers depth. And now we go into application of Cellix's biochips in blood vessels and endothelial cells lining up the capillary walls. This is a multi-step process where leukocyte switches from free-flowing into rolling state. This is where selecting molecules are involved. Following the leukocyte rolling, leukocyte activates. This is where chemokines and integrins play a significant role, and leukocytes switch into the activated states, which allows it to successfully adhere to endothelium. Following that, the leukocytes firmly adhere via LFA and alpha-4 integrins, which leads to transmigration of the leukocytes and the influence of chemokines through the endothelial layer. Typical leukocyte experiment running on the VenaFlux platform consists of the following steps. First, we coat the biochips with specified ligand. It could be VCAM, ICAM, or selectin. Then they are kept within the humidified chamber overnight. Prior to experiment, we coat the biochip with BSA to one non-specific binding. We can use the cell line sample or blood taken from the donor, and then we can isolate a certain cell type from that blood. When we use the VenaFlux biochip, cells are first seeded on the plastic substrate, and this is then grown over 48 hours inside a conventional incubator. When the plastic substrate inserted into a frame, and the top part is clamped against the cell substrate. This allows to run two parallel channels side by side, flowing the leukocyte cell suspension or isolated leukocytes through the microcapillaries. We take a cell sample from the epidermis, typically 2 million cells per milliliter concentration, put the cells inside the wall of the biochip, and then pull them through at the specified shear stress. During that time, the images are acquired, and this is a typical image. Then subsequently, they are analyzed using Biochips software or ImagePro+ software, and the numbers of cells appeared drawn on a graph depending on different treatments of the cell sample. First, we looked at THP1 cell adhesions to most common adhesion molecule observed in inflammation as VCAM1. And in this case, we've chosen to look at the effects of the antibodies on the cell adhesion. So what we do is we coat the channels with VCAM1 and then block subsequently the channel with anti-VCAM1 monoclonal antibody. Also, we use an IgG control as a reference and anti-selectin antibody as on the no treatment. We have 100% cells per field of view adhesion, and when we're using 50 microgram per milliliter concentration of anti-VCAM1 monoclonal antibody, we get about 50% decrease of cell adhesion to VCAM1. The reason that it doesn't go to completely 0% because perhaps the antibody within the monoclonal and the VCAM1 molecule has polyclonal. This is actually different if we're trying to inhibit the E-selectin molecule. So at 50 microgram per milliliter, this completely blocks the adhesion of THP1 cells on E-selectin. And in fact, it is actually rolling, which we observed in this case. It doesn't change for IgG control or for anti-VCAM antibody, but with the increase of the anti-E-selectin monoclonal antibody, we get a decrease of cells rolling on the E-selectin. Also, we used the different models where instead of coating with antibodies, we used primary Hurex to coat the surface of VenaFlux biochips. In this case, we used 4 different conditions. We have non-treated cells, THP1 treated with PMA, and then we subsequently tried using the Hurex, which were treated with TNF-alpha, and then combination of Hurex treated with Hurex don't allow any adhesion of THP1 cells because they don't express any selectin or adhesion molecules. And if we have them treated with TNF, we get a big increase, about 25-fold increase in adhesion. And this is some representative images of the cells adhering to HUVEX. We try to use also chemokines in combination with cell treatments, and also try to inhibit the adhesion of THP1 cells to HUVEX by using the antibodies. So in this case, HUVEX were treated with respective monoclonal antibodies for VCAM, E-selectin, or in some cases we use both of the antibodies together. As you can see, the stimulation of THP1 has no effect on cell adhesion, but the antibodies have effect. And in fact, if you use all two antibodies, we get the highest decrease of adhesion, up to 10% of cells per field of view. Similar experiment we repeated with PBMCs. Probably PBMCs are isolated from blood donors, and this is completely different. You can see that now the MCP1 has a significant effect. If we can see that the non-stimulated cells practically don't adhere MCP1. And also we can observe quite nicely the effect of antibodies, both VCAM1 antibodies, E-selectin, and two antibodies in combination. As a summary, the VenaFlux platform product mimics in vivo shear flow microenvironment unlike any other assay, and provides results which are physiologically relevant and translational. It's quite robust and easy to use. The biochips can be coated easily with proteins, or cells can be grown on chip. And the results of these experiments are reproducible and validated. We provide platforms which use everybody's needs. The biochips can be used with standard syringe pump, but also can be integrated with existing microscopy system and analysis software. We provide completely integrated VenaFlux platform for high throughput screening. This solution is flexible. The low volume assays can be run with whole blood and wide range of cell suspensions. This can be applied in a variety of different areas, and shear stress controlled by syringe pumps can vary from very low, which usually applies for leukocyte adhesion, to very high, usually